Have you ever stopped to wonder what happens when the sun dies? Not metaphorically, literally. What happens to our planet, our oceans, our atmosphere, when the very star that gives us life decides it's time to burn its final fuel? It's a question so big, so staggering that most of us tuck it away in the back of our minds. But the truth is, that day will come. Not in our lifetimes or even the lifetimes of thousands of generations after us, but the sun does have an expiration date, and when it finally reaches it, Earth's story will come to a fiery, irreversible end. Right now, somewhere out there, a star just like our sun has already died. Another world, maybe once full of life, has already been swallowed by its expanding stellar parent. That's the brutal truth about the universe. It doesn't wait. It doesn't care. And if we want to understand our future, we have to look to the stars that have already walked this path before us. The death of our sun isn't just a future event. It's a cosmic inevitability written in the laws of physics, unfolding slowly, silently, right now. But let's rewind for a moment. Before we talk about death, let's talk about life. Because the sun isn't just a massive ball of fire in the sky. It's the very heartbeat of our solar system. It formed around 4.5 billion years ago from a swirling cloud of gas and dust, a nebula, pulled together by gravity until pressure and heat ignited nuclear fusion in its core. That moment, the sun's first breath, was the spark that lit up our cosmic neighborhood, and everything we know exists because of that moment. The planets, the moons, the comets, even us. Our DNA carries elements forged in that ancient stellar furnace, carbon, oxygen, nitrogen, all born from that cosmic fire. And that same energy is what makes our planet habitable. Without the sun's heat, Earth would be nothing more than a frozen rock drifting through space. Temperatures would plummet to hundreds of degrees below freezing. Oceans would solidify into miles-thick sheets of ice, and every living thing would vanish. The sun's warmth keeps Earth at a comfortable average surface temperature of about 1700 Fahrenheit, but that's just one part of the equation. It also powers our weather systems, drives photosynthesis, controls ocean currents, and even dictates our biological clocks. When you think about it, the sun isn't just above us, it's inside us. It shapes every moment of our lives, from the food we eat to the air we breathe. But here's the catch. Stars like the sun don't burn forever. They live by a delicate balance, the outward pressure of nuclear fusion pushing against the inward pull of gravity. As long as there's hydrogen to burn in its core, the sun stays stable. This phase is called the main sequence, and our sun is currently halfway through it. Yes, halfway. That's not a comforting thought, is it? We often think of the sun as eternal, unchanging, but the truth is it's already evolving. Scientists estimate that each second, the sun fuses about 600 million tons of hydrogen into helium. That's an unfathomable amount of energy. So much that just 1 second of sunlight hitting Earth contains more power than all human civilization consumes in a week. And yet, even with that incredible output, the sun is gradually changing. It's growing hotter, brighter, and more unstable with time. In fact, the sun is now about 25% brighter than when it first formed. Let that sink in for a moment. This means that even without a dramatic explosion or sudden collapse, Earth's future is already being shaped by the sun's evolution. In the next few 100 million years, yes, million, not billion, Earth will begin to feel the consequences. Even tiny increases in solar radiation will have enormous effects. Our oceans, for example, will begin to evaporate. Not boil like a pot of water, but slowly, persistently, like a fever slowly rising in a sick body. That water vapor will act as a greenhouse gas, trapping even more heat, accelerating the warming. Eventually, temperatures will rise so high that liquid water can no longer exist on Earth's surface. And when the oceans go, life follows. Plant life will begin to die as carbon dioxide levels drop, a feedback loop caused by chemical reactions. In increasingly arid soil, without plants, oxygen production collapses. Without oxygen, you know the rest. Life on Earth will start to suffocate, not from war or catastrophe, but from the slow, steady tightening grip of an aging star. Some Scientists believe that within the next 1 billion years, complex life will no longer be sustainable on Earth, not because of human impact or asteroid strikes, but because of the sun itself. Imagine that, a world slowly turning into a desert of stone and dust, where the skies grow hazier, the oceans disappear, and nothing grows anymore. Not in an instant, but over millions of years. A slow extinction orchestrated not by violence but by heat and light. And we're still just in the early chapters of the story, because this is only the sun's midlife. The real transformation begins when it exhausts the last of its core hydrogen. At that point, the sun's core will collapse under gravity. And what happens next is something straight out of science fiction, except it's entirely real. But we'll get to that in the next section. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. So now you know the sun is not a constant. It's a ticking clock, an engine of life that will one day become an agent of destruction. But what happens when that engine starts breaking down? When fusion stops and gravity takes over? Let's explore the next chapter in the sun's life, and what it means for the fragile blue planet orbiting it. So, what happens when the sun runs out of fuel? It's a quiet beginning to a violent end. There's no sudden explosion, no dramatic flicker in the sky, just a slow, invisible shift inside the heart of the sun. Deep in its core, hydrogen, the very fuel that's been keeping it stable for billions of years, begins to run dry. When that final fusion reaction occurs, something ancient and unstoppable begins. Gravity, long held at bay by the force of nuclear fusion, begins to win. The sun's core collapses. Now here's where the story gets surreal, almost mythic in scale. As the core shrinks, the outer layers of the sun respond in the most dramatic way possible. They expand. The sun swells into a giant glowing monster, what astronomers call a red giant, not just bigger, but unimaginably huge. Its radius will stretch beyond the orbit of Mercury, then Venus, and eventually it's coming for Earth. That's not poetic exaggeration, it's literal science. The sun, which today measures about 865,000 miles across, will expand more than 100 times its current size. Imagine the entire sky consumed by a bloated red inferno. The light we once depended on becomes oppressive. The sky burns orange and crimson day and night. And Earth, if it's not already scorched beyond recognition, will be swallowed whole. Let that image settle for a moment. Our planet, drifting into the belly of the sun. But even before that final engulfment, Earth will already be unrecognizable. The heat alone from the expanding red giant phase will vaporize what's left of the oceans. Mountain ranges will melt like wax under a blowtorch. The crust of the Earth could liquefy, and our atmosphere, already stripped of moisture and oxygen, will be torn away by solar winds so intense they'll make current solar storms look like gentle breezes. And yes, this is still part of a natural stellar process. The red giant phase marks a new chapter in the sun's life. While the outer layers swell, the core continues collapsing until temperatures soar even higher, hot enough to ignite a new kind of fusion. This time, it's helium burning into carbon. For a brief period, the sun becomes even more unstable, pulsating like a beating heart. These pulses cause it to shed massive amounts of its mass into space, giant waves of plasma and dust forming what's called a planetary nebula. Now, don't be misled by the name. It has nothing to do with actual planets. A planetary nebula is a glowing shell of gas and stellar debris, ejected by the dying star in its final act of beauty. In fact, many of the most stunning images you've seen from telescopes, those colorful, symmetrical cloud-like structures floating in space, are remnants of stars, just like our sun. But here's where it gets even more fascinating. While the EC outer layers drift off into the cosmic void, the sun's core is left behind. A tiny, ultra-dense remnant called a white dwarf. No fusion, no light generated from within, just the remaining heat of a collapsed core, slowly cooling over billions of years. This white dwarf will be no larger than Earth. Yet it will contain more than half the mass of the original Sun. It's like compressing a star into the size of a planet. Dense, dim, and silent. It won't explode. It won't ignite again. It will just sit there, a cosmic tombstone for a star that once brought light to an entire world. But let's rewind a moment, because there's one haunting question we haven't answered yet. Will Earth survive the red giant phase? The answer is complicated. Some models suggest Earth might narrowly escape being engulfed, pulled outward by the loss of solar mass and shifted into a wider orbit. But it won't be a lucky escape, because even if our planet isn't consumed, it will be left a scorched, lifeless rock. No oceans, no atmosphere, no hope of habitability. The gravitational tug-of-war during the Sun's expansion could tear the planet's orbit into instability. And even if it remains in place, the surface will be sterilized by radiation and heat. Some scientists even theorize that Earth could be entirely incinerated, its very crust disintegrated under solar pressure waves. Others propose that Earth could spiral inward, pulled by solar drag and magnetic forces, eventually plunging into the Sun's glowing belly during its final pulsations. Either way, the message is clear. Whether consumed or abandoned, Earth's fate is sealed. But here's the thing, the Sun isn't unique. This isn't some catastrophic anomaly. This is what stars do. What's coming for us has already happened to billions of other planetary systems across the universe. And in some poetic way, the death of the Sun is also a kind of rebirth. The elements thrown into space, the carbon, oxygen, nitrogen, will drift through the galaxy. Eventually, they may become part of new stars, new planets, maybe even new life. In fact, everything that makes you you was once part of a star that died long before our Sun was even born. It's strange, isn't it, to realize that death in the universe isn't an ending, it's a beginning. But we're not finished yet. There's still so much more to this story. Because while Earth's chapter may end, the solar system continues. What happens to the other planets? What will the night sky look like without a shining sun? And just how long will that lonely white dwarf keep glowing in the dark? So beyond the Sun is gone, at least the Sun as we once knew it, no longer a brilliant life-giver, no longer the center of warmth and energy. What remains is a pale, ghostly ember, a white dwarf, glowing faintly where a mighty star once ruled. And Earth? Whether it was swallowed whole or left a burned-out husk, its time has passed, but the story of our solar system, that doesn't end with Earth's destruction. Imagine the scene, a hollow, dim solar system, stripped of its golden glow, orbiting a dying remnant. The outer planets Jupiter, Saturn, Uranus, Neptune still exist, silent sentinels in a darkened realm, but they too are changed. Without the full power of the Sun, their atmospheres cool, their clouds, once painted in swirls of amber and sapphire, begin to settle. Storms like Jupiter's great red spot fade into stillness. Saturn's rings, once brilliant under solar light, drift and disintegrate, their particles drawn into slow collisions over time. Yet there's something eerily poetic about it all. These gas giants, distant from the Sun's furnace, may endure longer than the inner planets. They will remain in orbit around the white dwarf for billions, perhaps even trillions of years. Their moons, however, that's another story. Some of those moons, like Europa, Enceladus, or Titan, may have once held the tantalizing possibility of life beneath their icy crusts. Subsurface oceans warmed by tidal forces, shielded from solar radiation, once whispered promises of alien biology. But as the solar system cools, so too does their internal activity. The heat fades, the liquid oceans freeze solid, and whatever mysteries they once held are locked forever in ice. But the most haunting part of this future isn't the silence, it's the loneliness, because a white dwarf doesn't shine forever. It simply cools, slowly, gradually. For billions upon billions of years, its pale glow dims, slipping ever closer to absolute darkness. And once its last flicker of warmth is gone, it becomes something we've never seen, something purely theoretical in our current universe, a black dwarf. Now, let's pause there. Because this concept, it's chilling, and not just in temperature. A black dwarf is a star that has burned out entirely, a dead remnant, emitting no heat, no light, nothing. It's the final evolutionary stage of a medium-sized star like our Sun. But here's the cosmic twist. The universe isn't old enough yet for a single black dwarf to exist. The process takes so long, trillions of years, that not even one has had time to fully form. Think about that. Our universe is still in its early days compared to what's coming. So in this distant future, long after humanity has vanished, or perhaps moved on to other worlds if we survive long enough, our Sun's ghost will be among the first to take that final plunge into darkness. A black dwarf, invisible, undetectable, floating alone in the abyss, a cosmic gravestone that marks where light once lived. But even then, the story doesn't truly end, because even in this cold, dead solar system, gravity still works its strange magic. The white dwarf, or black dwarf if enough time has passed, still has mass and its gravity still shapes the orbits of the outer planets. Occasionally, a comet from the distant Oort cloud may drift inward, spiraling toward this lifeless core, only to fall silently into its pull, a final act in a story that's taken trillions of years to tell. And what about our galaxy? What about the broader universe? Well, here's where things grow even more unsettling. While our Sun fades into shadow, the Milky Way itself will be on a collision course with another spiral giant, Andromeda. In roughly 4 billion years, right around the time the Sun enters its red giant phase, these two galaxies will begin to merge. Stars will slingshot past each other, pulled by gravity into chaotic dances. New stars will ignite from compressed gas clouds, and new planetary systems will be born. It's a celestial rebirth on a galactic scale, but not for us. Not for Earth. Our story will already be over. That's the cruel beauty of the cosmos. It never stops moving. Even when entire worlds vanish, new ones are born. New stars take the place of old ones, and just as we once looked at other stars and wondered about their planets, one day alien astronomers may peer into the ruins of our system and wonder what once lived here. What stories were told beneath that pale sun? Who once called that scorched blue marble home? Perhaps in that future, all that remains of us is a whisper in the gravity fields, a faint echo of a civilization that once reached for the stars, before its own star reached back and swallowed it whole. But maybe we don't have to wait until the end to wonder what comes next. Maybe the real question isn't when the sun will destroy Earth, but what will we do before that moment comes? So now we know how it ends. The Earth, a memory, the sun, a faint cinder, the sky, once alive with warmth and light, now an eternal shadow. But what does all of this truly mean for us? It's one thing to know the science, to chart the course of stars, measure the expansion of red giants, and map the lifespan of atoms across the vastness of time. But behind all that data, all those calculations, is a deeply human truth. A truth about legacy, about impermanence, about how fragile and how extraordinary it is to be alive in the briefest flicker of a star's life. Because that's what we are, stardust on borrowed time. The sun that nourishes us today, that paints the sky each morning with fire, is not eternal. It's not infinite. It's just one chapter in an ever-turning cosmic story. We're living in its golden hour, a moment of warmth between the cold of creation and the silence of the future. And when you think about it like that, everything changes. Suddenly the everyday feels sacred. That sunlight falling across your face, that's ancient nuclear fusion, traveling 93 million miles to warm your skin. That food you eat, the air you breathe, the water you drink, all powered by a star that's slowly dying moment by moment. And somehow, that makes it even more beautiful. But it also raises questions, big ones. If Earth's days are numbered, what then is our responsibility? Are we just spectators in this slow apocalypse, or can we shape what happens next? Can we as a species find a way to outlive our sun? Some scientists believe we can. In fact, some believe we must. You see, this isn't just about cosmic curiosity, it's about survival. Visionaries like Carl Sagan and Stephen Hawking have long warned that humanity must become a multi-planetary species if we want to endure. Because no matter how advanced our technology becomes, we can't stop the sun from dying. We can't bargain with physics. but we can look beyond Earth. Today, space agencies are exploring Mars, mapping Europa, dreaming of interstellar travel. Projects like the Breakthrough Starshot initiative envision sending tiny probes to neighboring star systems. Space habitats, solar sails, terraforming, ideas that once belonged in science fiction, are slowly moving into the realm of possibility, and maybe, just maybe, one day, far into the future, our distant descendants, human or otherwise, will look back on Earth not as a final home but a birthplace. The cradle of a species that refused to vanish with the light of its first star. But even if we never leave this planet, even if our story ends here, wrapped in heat and flame, isn't it still incredible that we got to exist at all? Think about it. Out of billions of years, out of infinite stars, you were born in a fleeting moment when life could thrive. You get to breathe air made from ancient atoms. You get to think, to feel, to wonder. You get to ask questions like, what happens to the sun? And more importantly, what does it mean for me? That's the magic of knowledge. The universe doesn't owe us answers. But still we search, we build telescopes that reach into the past. We launch satellites into the void. We craft stories and science and dreams, all because we want to understand. And in doing so, we become more than just creatures waiting for extinction. We become explorers of time itself. So the next time you look up at the sky, remember this: every ray of sunlight you see is a gift from a dying star. A reminder that beauty doesn't last forever, but it exists, and that's what makes it precious. And maybe, just maybe, the true purpose of life isn't to outlast the sun, but to shine just as brightly while we can. If this journey stirred something inside you, if it made you wonder, reflect, or even just feel a little more connected to the stars, then let's keep this conversation going. Share this video with someone who loves space. Drop your thoughts in the comments. What do you think will happen to us when the sun dies? And if you enjoyed this cosmic exploration, don't forget to like the video. It tells the algorithm that this story was worth telling. Thank you for being part of this journey, because in the end, we're all just stardust trying to understand where we came from and where we're going next. Until next time, keep listening to the whispers of the cosmos